Okay, so just as a refresher really fast, the product rule and the quotient rule, because we're getting ready to use these. So we always, it's, first term, second term, so UV. So we always write them in that order. So it's U V prime plus U prime V. So with product rule, it's the inner terms. Quotient rule, it's the outer one. So it's U prime V minus UV prime divided by the bottom squared. So V squared. And so just keep that in mind, like you're going to have to just ingrain that in your brain as we go. So we did 14 last week, which was a quotient rule to kind of wrap up. And then these next problems say to find dy dx, support your answer graphically, which we're not, or you can support your answer graphically. Obviously, we're not doing that. But these are a mix of quotient rule and product rule, and sometimes you can have a product rule within a quotient rule.
Don't know. Because you can like multiply and then have to divide later.
Or you could be dividing and then have to multiply within the top. So, anyways, those make for a good time. When we get to 22, just be prepared for a good time.
I can't wait.
I'm just like so excited.
You can hear the excitement in my voice.
Honestly.
All right, so 16, we've got x squared plus 1 times x cubed plus 1. So, what option is this?
The product.
It's a product rule. So, dy dx, or y prime, however you want to do it, is equal to, and I often won't write the dy dx, just, this might be the last time I write it. I usually just take the derivative and go. So, we are uv, and then we do the inner terms for this. So, x squared plus 1 times, what is the derivative of x cubed plus 1?
3x squared.
3x squared. Yeah. Then plus the derivative of the first term. So the derivative of x squared plus 1. 2x. And then times x cubed plus 1. And I often end up putting every little piece in parentheses just because, one, you can go back and kind of see it.
Like which one?
Yeah. And, if you're having a hard time with getting this stuff written right, you can, what I would almost say is write this and then do, okay, this is u v prime plus u prime v. And, almost, write it out in, the letters of what it should be and then actually go through and take the derivatives and stuff because it does kind of... Usually product rule I'm okay with because it doesn't really matter what order. If you do them in the wrong order, it doesn't really matter. Mm-hmm. Quotient rule does matter, though, because of the subtraction aspect of it. So I tend to write it out. Or at least, when you first get, your quiz or test or something, write it once at the top of what the rule is. So that way you can just kind of use that.
Like I do with SOHCAHTOA every time we have... Literally, I always write it.
So now I've done the calculus part. Now it's just... algebra. So that's going to be 3x to the 4th plus 3x squared, and then plus 2x to the 4th plus 2x, and then obviously we would just want to write it in the right order. So that's going to be 5x to the 4th plus 3x squared plus 2x. Now, some people might ask, couldn't I have FOILed this and then taken the derivative? Well, yeah, you can if you just, dying to, but
That's just more.
it technically takes a little bit more work to do that.
Yeah.
So probably not the recommended way to do it, but you could do that. Or if you're like, I don't know if I did it right, I feel like I may have done the product rule wrong or something like that, you could always go back and check it by doing it that way.
Right.
So, anyways. 18. Y is equal to x squared plus 5x minus 1 over x squared.
Quotient rule.
So this one's a quotient rule. So I've got, let me do it in green. So I've got u over v, though they kind of look the same, u. So my quotient rule is u prime v minus u v prime over v squared. So, what is the derivative of the top?
2x plus 5.
Okay. And then times the bottom, so times x squared, minus, and this is where even if you don't put parentheses, say around the x squared or whatever, got to make sure you put it around the second half, because this minus sign, when you start getting negatives up in here, it can get confusing. So you've got to make sure you're subtracting those terms when you get there. So now, copy down the first one, or the top one, so x squared plus 5x minus 1 times the derivative of the bottom, 2x, all over. All over is going to go with you forever. Oh wait, x, sorry, yeah, x squared squared, yeah. I think I was looking at the v for some reason, so I was like, yeah, just x squared, and then I was like, wait, no. So yeah, so it's x squared squared, and then always remember when you have a power raised to a power, you multiply the exponents. Some people get a little confused with that, and again, it's the algebra that kills you, so feel the need to point it out. So this is officially, where we found the derivative here. So now I can multiply stuff. So I've got 2x cubed plus 5x squared. Now I'm going to go ahead and do this negative as I multiply this 2x through everything as well. Okay? So that way I don't have to worry about it from here on out. I already have the signs as they need to be. So this is going to be negative x squared times 2x. That's going to be negative 2x cubed. Then I've got negative times 5x times 2x. That's going to be negative 10x squared. Then I got negative and negative 1, so that's going to become positive times 2x. So that's just going to be plus 2x. And then now I just need to, yep. Over x to the fourth. Sometimes I'll just work on the top and then simplify and then put it all over the bottom, but I don't want to do that right now and confuse people, so. All right, so then on top, my 2x cubes cancel. And then I'm left with, negative 5x squared plus 2x over x to the fourth. Which it is completely fine to leave it that way. But I am going to go ahead and reduce it down and show you how else it could be written, because when you get to multiple choice questions on the AP exam, sometimes what they may do is they may just say, what is the derivative of y? And they may basically set it up like this, and they may leave it because they just want to see that you know how to set it up. But the multiple choice could also have the option being down to here, but it could take it farther. So a lot of times what I'll do when I'm demonstrating problems is if it can be left where it is, I'll show you that, but I'm also going to show you how to take it farther so that as you're looking through your multiple choice options, you can see which, well, this isn't how we got it in class. Well, yeah, because there's different levels of where you could leave it. So one option is I could take an x out of everything here on the top. And so here, I'm going to circle this. So this is one option we can have. I can take an x out of everything on the top, so that would leave me with negative 5x plus 2 over x to the fourth. And so then this would reduce down to basically being over x cubed. So that would leave me with negative 5x plus 2 over x cubed. So that's another option of where I could leave it. So there. Now, the final option that you could see, and I want to say, before I say it, let me look. This next way is the way the book is going to leave the answer. Okay? So the other option then could be that we take this and we split this into two pieces. So it would be negative 5x over x squared, which is going to reduce down to negative 5 over x plus 2 over x cubed. So all of these are options. I would say at a minimum, you should take out the x because an x can be taken out of it. It's very unlikely that they're going to leave it here. I'm more so showing you that because let's say there wasn't an x in both pieces on the top. We would just go from blue to blue and skip this middle step here. But because you can take an x out, I would say plan to take an x out. If this happened to be in a short answer question on the AP exam, go as far as you can. Always give, well, I don't want to say always give more. Give more, not less.
Yeah.
Because there are actual people who sit there and grade them, and they have things that they're looking for. And the better your answer is, the more points they give you. So, this isn't inclined to, on its own, be a short answer question, because short answer questions usually have 3 to 4 parts for calculus, but it could be. So, anyways, just want to point that out. All right, now on to 22.
Oh man. How long is this problem?
It was about half a page for me.
Yeah.
So 22, y equals x plus 1 times x plus 2 over x minus 1 times x minus 2. So now, in a sense, yeah, this is a quotient rule, okay, because I've got a top and a bottom and I'm taking the derivative.
Mm-hmm.
Within that, if I don't change anything as it stands, when I take the derivative of the top, okay, I have to take a product rule. So it's like a derivative and a derivative. We don't technically know how to do that yet, okay, because that's like in the next chapter, I want to say. So what we're going to do is we're going to actually FOIL the top and FOIL the bottom and then take it that way.
So overall, you're gonna be doing the quotient rule?
Yes.
Okay.
I am going to do the quotient rule. I could not FOIL anything, and I could basically, when I take the derivative of the top, because I'm taking the derivative of the outer two terms, take the derivative of the top, I would then have within that derivative another derivative because it's a product rule in there, which would mean I would have to do the first one times the derivative of the second one plus the derivative of the first one times the second one, and that would just be that one piece.
Oh, that sounds terrible.
Which, up here, we said, where was it? I said, well, we could have multiplied this through and then taken the derivative, which would have made our derivative easier, but it would have made a lot more math. In this situation down here, you're going to prefer to FOIL it.
Yeah.
Because otherwise there's a lot more calculus involved and a lot more room for error.
Yeah.
So, I'm going to rewrite this as x squared plus, is that 3x plus 2? Gracious, I have the hiccups. Over, that was a big over. X squared minus 3x plus 2. And so now I'm going to use the quotient rule with that, which still is a little bit long, obviously, because I now have basically a trinomial on the top and the bottom. But it makes it a lot easier than doing a product rule within a quotient rule.
Yeah.
Okay, so y prime is going to be
2x plus 3 times
yep, so the derivative of the top times the bottom. So the top times, which is
2x minus 3.
Now,
Oh, that was fun.
for now, I am going to write it this way. I may need to factor it back to this, potentially for things to cancel, because sometimes it works out where things cancel nicely, sometimes it doesn't. So I'm going to leave it this way for now, but I may end up having to factor it back. So x squared minus 3x plus 2 squared. This is one of those problems where I would be inclined to work on the top and then put it back over the bottom, but for the sake of doing examples, I'm going to go ahead and write it over the bottom every time. But when you do your homework, if you want to like just work with the top and get that all simplified and then put it over the bottom, that's fine too. Okay, so on the top, I now have, I better start over here because I feel like that's going to be a lot. All right, so I've got 2x cubed minus 6x squared plus 4x plus 3x squared minus 9x plus 6. That's just the first part. Now, I am going to go ahead and multiply the negative through so I don't have to worry about it. So that's going to be negative 2x cubed minus 6x squared minus 4x. Now this negative and the negative 3 are going to cancel, or like the negatives are going to cancel, so these are all going to be positive. Okay, y'all see that? Okay, so I'm going to have plus 3x squared plus 9x plus 6. It barely fit. Should have slid it over a little bit farther.
And it just like gets smaller as you go.
All right, so I am going to go ahead and write it all over. And I might just honestly do like the bottom square just so I don't forget about it, but you don't necessarily have to write it in. That's another way you could do it. Now, if you get to the AP exam, don't like leave blanks in your work if it's a short answer question, because they're going to be like, what are they doing?
What is happening?
But, all right, I'm going to underline the cubed terms 3 times so that I can try to have some semblance of order here.
Well, that makes sense.
Oh, wait, those cancel. So those are gone.
Oh, never mind.
2x cubed, negative 2x cubed, gone.
They're gone.
Let's see.
This one's square.
Negative 6x squared. I've got 3x squared. I've got a negative 6x squared. And I've got a positive 3x squared.
Yeah.
Is that it? Okay.
Yeah.
So the 2 3s, because they're positive, cancel with one of the 6s. So I'm going to go ahead and cross those out. So all I'm left with is a negative 6x squared in that regard. And then as far as just my x terms, I've got 4x, I've got negative 9x, I've got a negative 4x, and a 9x. So all my x terms cancel, right? Is that what y'all got?
Yes.
All right, so 4x cancels with negative 4x, negative 9x cancels with 9x. And then finally, I have all that's left is a 6, or 2 6s, so that's plus 12.
Isn't
That worked out nicely. I like that.
So now, x squared minus 3x plus 2 squared. So then, is this how they leave their answer, or do they change it? Let me see. All right, so they actually leave it this way. The only thing that they do differently is that they do 12 minus 6x squared to not have the negative out front.
Oh, okay.
I'm trying to be fancy like that.
So again, I would have just left it here, but always good to realize that this is the same thing, because when you get to the AP exam, if they were to write it with the negative inside, then that way you're used to it.
Wait, did you just like take the
I just,
squared away?
I forgot about the square on the bottom.
oh, no, I just didn't write it.
Oh, I was like, this is just disappear.
I wish.
Oh, because that makes sense, because it would just.
I think I saw the squared on the X at the top and was like, oh yeah, it's there.
Yeah, Yeah.
But anyways, but they will do it like that because of they just don't want the negative out front. I guess I don't really know why they do it otherwise, but anyways.
So if you were to put, like, if this was one of the questions on the short answer or whatever, if you were to put the first one, would you get the answer wrong?
You shouldn't because it's the right answer. It's just written differently. I was just more so showing you this for the standpoint that if it's a multiple choice question and you're like, my answer isn't there, that's why your answer is not there.
Yeah. Unless you're just totally wrong.
Yeah.
And then your answer's not there.
But I mean, if you're like, well, this answer kind of looks like it, I just wanted you to like realize because again, it's the algebra side where all you did was flip the terms. What is it? The commutative property that allows us to just flip the terms. That's all that they did.
Okay. Okay, that wasn't as bad as I thought it was gonna be.
Yeah. When they work where you can do that and then things cancel nicely, they're not really that bad. However, when they don't cancel, or when you get to the point where you then have to start factoring stuff out, like hypothetically, if this had given us something up here that could have factored into like x minus 1 or x minus 2 by the time we were all done, then I would have rewritten the bottom as x minus 1 and x minus 2.
Because then you could have like crossed it out. Okay.
So again, the exam, they could have potentially left this in factored form on the bottom. So again, that's another thing that the top might look like this and the bottom might have been x minus 1 times x minus 2 squared, the whole thing squared. So again, just things to look for when you're doing a multiple choice question. Don't be alarmed if your answer isn't there. See if it's written in a different way.
Okay.
So, okay. I'm going to have you write down all of this stuff and then I'm going to explain how we do these problems because these are going to they're going to look different than any problem you've ever probably done before. All right, suppose u and v are functions of x that are differentiable at x equals 2 and that u of 2, so this is problem 24, u of 2 is equal to 3, u prime of 2 is equal to negative 4, v of 2 is equal to 1, and v prime of 2 is equal to 2. Find the values of the following derivatives at x equals 2. Okay, so the only reason the at x equals 2 is relevant is because that's what has been plugged in here.
Okay.
Is that it's saying if x was 2, this is the value for u, this is the value for v, and then these are the values for their derivatives at those points. So now, this is a 4-part question, okay? So, A says d dx of uv. I'm going to go ahead and write all of them, but like the quotient ones, you might want like 2 lines for. The product ones, you really only need 1 line for. And that only if you don't want a fraction written in the same line. For the quotient. d dx of u over v C is d dx of v over u, and d is d dx of 3u minus 2v plus 2uv. That one you're going to need a couple lines for potentially, but.
I'll just write that when we get to it.
All right, so basically, you're probably looking at this like, what in the world am I supposed to do? Basically, we're taking the product rule for u times v. Okay? So, I'm going to pretty much always, when it gives it to me this way, write it out in letters and then replace with numbers. Because otherwise it can get confusing. So, product rule is u v prime plus u prime v. So now, I've already done these up here, or these were given to me. So u is 3, so 3 times v prime was 2, so plug in 2, plus u prime was negative 4, and v was 1. And so as simple as 3 times 2 is 6, minus 4 is 2 is your answer.
Okay.
So you kind of see what I mean, where I'm like, it's kind of like, it's different, but
It's easier because they give
it's
you the,
easy because you're just plugging in numbers.
Yeah, 'cause
You're
they
not
give you
really
the
taking
stuff.
the derivative.
So as long as you know what the product rule is.
Yeah. Well, and then like B and C are the same thing, just reversed.
Okay.
So, like, because obviously it's U over B and then V over U. So, U over V, this is going to be our normal formula that we have for U and V.
Mm-hmm.
So, U prime V minus U V prime over V squared. So then, let's see, U prime is negative 4, V is 1, minus U is 3, V prime is 2, over V squared is just 1 squared. Okay, so obviously that's just going to be over 1, so it doesn't really matter. So I've got negative 4 minus 6, so that's going to be negative 10. So that one works out nicely. So then V over U would be V prime U minus, oh goodness, this is confusing, V U prime.
So it's like everything.
It's hard when the letters are backwards for the letters that we normally use. So yes, it's backwards because it's always the derivative of the top times the bottom minus the top times the derivative of the bottom.
Okay, so then it's going to be U squared?
Yeah.
Okay.
Which is why a lot of times I actually won't say V and U when I'm doing it, because when you get to problems like this, it gets confusing.
Then
I
you're
will a
like,
lot of times be like, the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. That's typically the words that I'm going to
Yeah.
say. I've been saying U and V while we're getting used to it, but when you get to these, it can get confusing. So you kind of just have to know, oh, I flipped it, so it's going to be, everything's going to be kind of different. So V prime is 2 times U is 3 minus 1 times U prime is negative 4 over U squared is 3 squared. So this ends up being 6 plus 4, so that's 10 over 9. Now, this bottom one, it's a little different because the temptation here is to say, well, when I take the derivative of 3u, the derivative is 3. But that's not the case, because you have to remember that u is representing a function. So it's 3 times some function. And so when we do this, this is going to be 3u prime minus 2v prime plus 2 times, and then a lot of times I will bracket this off because this 2 is being multiplied by u times v. But u times v is going to be a product rule.
Yeah.
So 2 times uv prime minus u prime v. And in this case, because I already found this number up here when I did this derivative.
Wait, is it minus or is it plus?
Plus, sorry. Yep, plus. When I already found this derivative up here, okay, so this value was 2, I'm just going to use this and plug it in here instead
yeah,
of actually
smart.
doing the work again,
Yay.
okay? Because if I can save steps, I'm going to.
Yay, let's work.
So then this is going to be 3, u prime was negative 4, minus 2 times v prime was 2, plus 2 times, and then this number was 2 that we got. And obviously there's a level up. You have to be pretty confident your number was right to begin with.
Yeah.
However, if you got it wrong the first time, you're probably going to get it wrong the second time because more than likely you're using the wrong formula.
True.
So then we get, what is this, negative 12 minus 4 plus 4. So this ends up just being negative 12. So
So bad.
it's not bad, it's just different.
Yeah, it's definitely different, but I kind of liked it.
Especially like part D, because like I said, people tend to be like, well, 3u, that's just 3 because 3x is just 3. And it's like, but that's not the case, because you have to remember, that's why it's so critical, the part that it says about u and v are functions of x, because that means that there are pieces that go with that. Let's see. I think we're going to go ahead and stop there and wrap this section up basically more or less tomorrow.
Okay.
Oh, well, we might not wrap it up tomorrow. There's kind of a lot left.
Oh.
But I don't think they're not as long. Basically, just to kind of intro what we're going to be doing tomorrow then, we can take, so what we've been taking is the first derivative. But we can actually take an infinite amount of derivatives if the problem allows for it. So like if I had like x to the 4th and I told you to take the derivative of that, you would tell me it was what? 4x cubed. So now that's the first derivative. But I want the second derivative. So we're going to take the derivative of now 4x cubed. So what would that be? 12x squared. So now I want the third derivative. So we're going to take the derivative of that. So 12x squared, the derivative would be 24x. So then I want the fourth derivative. So 24x, the derivative of that would be 24. And so then I could technically take one more derivative and the answer would be
0.
0. Okay? So I can keep taking the derivative.
That makes sense.
Okay.
So that's part of what we're going to do tomorrow is a couple of problems. So we'll write it as y prime, y double prime, y triple prime.
Oh my
Not
god.
the triple prime.
But when you get to the 4th, we actually put a little parentheses 4 above the y, and so on and so forth.
Okay.
So those problems actually go super fast. They take up a lot of space, and so then let's say then that I wanted the 7th derivative of what you just did.
The 7th?
Once you get to 0 and I say that was the 5th derivative, well, the 6th derivative is still 0 because it was 0 to begin with, and the derivative of 0 is 0. And so then I want the 7th derivative. The derivative of 0 is 0. And so it kind of just keeps going. Now, that was kind of an obnoxious example of what we're going to be doing, but those problems should go relatively fast. The other thing, the first thing we'll do tomorrow actually is determining, it's a multiple choice question. They say determine which number is the slope of the line. So basically we're taking the derivative, set it equal to 0, and figure out what the slope is. And then some of them will say to find an equation for the tangent line.
Mm-hmm.
And so we basically find the slope, the things that we've kind of done before. But now it's involving a quotient rule or a product rule to get to our tangent value. So, anyways, thanks. So, anyways, that's basically that for tomorrow. Those are the big things. And then there might be a word problem or two that we look at. I have to see if that's what this goes with or not. I think it is. But the nice thing about the word problems is it kind of looks like this problem once we get it all set up. Once you know how to read it, this is all you have to do.
Oh, okay. Okay, that's nice.
So that's a scenario where they could give you a short answer question potentially on the exam using this stuff, is by giving you a word problem. I haven't really seen those in the practice test, but it could happen, so always worth going over because they can also show up in multiple choice, obviously. So I am going to go ahead and give you problems up through where we are right now, just so that if you don't want to wait and have to do all of these at once, because it does kind of end up being a decent amount. That way you have them, but they're not due tomorrow or anything. So 1, 5, 7, 11, 15, 19, and 23, which 23 will basically be just like the one we just finished. So, and then we'll pick up and add a few more, about 8 more tomorrow. So.